Welcome to yet another session on business statistics. Today we will see decision trees in stages. We will see decision tree single stage and decision tree multiple stages. In the last session we saw probability tree and an example on that, and also generally understood how to build a decision and probability oriented decision tree. In single stage decision tree we will have course of action 1, course of action 2, state of nature with probabilities and state of nature with probabilities. So what you do is that you arrive at the expected value under these circumstances, so much so under these circumstances. Now what you will do is that out of this you compare whichever is better and that becomes your decision. And that is what is single stage decision tree. In multiple stage, the situation similar to single stage replicates few times. So what you do is that in multiple stage you do an operation called rollback option or rollback operation. So in this scenario you work out the expected return or expected value at the rightmost end, and then you work out for different course of action. Now what you do is that you take the best out of that, and that will be at this point, that will be the effective returns, and once again come back, and then you have further status of nature, and then you work out another stage of expected values and move on like this. So what you do is that you roll back from here to here you come, from here to here you come, and then here to here you come. So at this decision node, best out of these two expected returns will be there, and then based on the status of nature you come down to this decision node, before which you will calculate what we have done similar to that to arrive at the expected returns at this stage. So out of these two you take the best one, and that is what is the net expected returns in the entire chain. So obviously when you move from here to here, when EV1 is better than EV2, this goes off. Similarly, when you arrive at this point where you have arrived at the new expected values EV3 and EV4, and if EV3 is better than EV4, this goes off, and then you move back, and that will the net expected value will be EV3. Okay, this is the way the rollback method is carried out. We will see by way of a couple of examples in the PowerPoint presentation. Now we will see decision trees under single stage and multiple stages. Now this is a very interesting situation where a manufacturer is operating his plant at full capacity. His marketing department comes up with a forecast of 1,000 more units can be sold in the next year. So his decision need to whether to subcontract to meet the additional demand or go on a overtime. And the probabilities of low, medium and high demands are shown here. And the costing department comes up with the payoff matrix for low, medium and high demand for subcontract and overtime. Now when you convert this into decision tree, this is how it looks like. So the course of action subcontract or overtime, the state of nature with the probabilities low, medium and high are shown here on both the situations. Now this is the payoff. Now let us look at it how the payoff is in case of subcontract is the payoff of 10k multiplied by 0.1, which is the probability, and similarly for medium and high. So you get a net payoff or expected payoff as 46k. Similarly, when you work it out for overtime, it is 68k. Since overtime the net expected payoff is more than the subcontracting, so the choice for the manufacturer is to go for overtime, and he would be getting 68k as the expected payoff. This is a simple straightforward solution wherein you arrive at the net effective payoff or expected payoff at the right extreme. Now let us look into the decision tree under multiple stages. Now, as I have already expressed to you, in multiple stages you have to do a method called rollback method. We will see how we are going to do that in this case. Take some time to read this situation fully. You can pause it on for some time, read it fully, and then we can proceed. Now to quickly explain to you, One Stop Retail Solution is a software company and he wants to bid for providing a solution to a retail chain operator. The cost of the bid is given as 10K and he has a choice, either use server based or cloud based, and he has a choice to select three products A, B and C, where A is 100% sure shot, but only thing is it's a bit costly, whereas B and C needs customization, and the probability of success of these B and C being implemented is given as 0.6 and 0.5 in respective platform, and so much so for C is 0.8 and 0.7. Now, in case he fails to implement product B or C, he has to necessarily buy product A and install. And if he wins the contract, he gets an advance of 500K to start with. So under this situation, we will explore how this multi-stage decision tree looks like. This is how it looks like. Now the course of action, bid or not to bid, and getting the contract and no contract is a state of nature. It's a question of probability, and he has to decide server based or cloud based, and he has to buy. If he buys product software B, then what will be his cash outflow and then the associated expected returns, so much so under C. And if he goes for cloud based, the product B and C, the prices and the expected returns. Now let us take one arm and thoroughly analyze. Now when you go through this, the expected returns for having chosen B, which has got a probability of 0.6, is that the returns or the advance he receives is 500 and the product cost is 70. So the probability or the expected returns at this stage is 258K. Likewise, we can work out for all the other things. Only thing is, if he fails, you have to add the software A cost, which is 120 here, and in a cloud base it is 130 here. So all the four cases are built. So at this stage, it looks that the product B, okay, seems to give the better expected return, that is 382K. And what you do is that you roll back now. Now out of these two, your choice is product B, and out of these two, your choice is product B. And this gives a 382K return, and this gives a 355K return as the expected return. Now we have to move one step further down, because there is an associated probability of getting the contract or not. So from here you move back and then come to this point. Okay, so obviously when you move this is not a choice, this is not a choice, and this will not be a choice. So you move on here. From here the probability is 0.5, multiply this, you get this 196. And here, because you don't get the contract, but you would have spent money of 10K, and that is what is a loss. And now when you come to this stage, this 10K has to be subtracted from this, and then you get an expected return of 186K if you adopt this route. Okay, right? Now the choice for the software solution provider is go for server based product B, or it could be wiser to choose product A and just implement it, because the sure shot, you don't need to do much of customization. Hardly the difference between these two are only 2K. So go for this option. So this is the way you look at a multiple stage, wherein you have to roll back and remove those arms which are not giving any benefit and come back. So at the beginning of the stage you can decide.